Okay, so the Cubeviz visualization tool is another configuration of JDAViz like the ones you've seen previously. The viewers are configured somewhat differently, as you'll see. I'm going to show you how to load in a data cube, and we're going to be using a near-spec IFU simulated data cube that's actually been run through the JWST pipeline. Without further ado, let's proceed. We start with some imports. So, hit enter to run the cell. And we want to grab this file name from box, which is our simulated IFU data cube. To do that, we're going to use the download file method. And we want to enter the file name, tell it to cache the data. So, shift enter to run that. The next step is to launch the Cubeviz application, and you do that very similarly to how you do the others. Just type Cubeviz equals Cubeviz, up for the capitalization, and then we're going to launch the app with the command cubeviz.app. Oh, and you should see the viewer appear. And I'll wait a moment. Actually, let me minimize this file browser here. Okay. The first thing we need to do, first I'll populate the data in Cubeviz by going down. And what you want to do as we go through this demo is I've got a set of UI instructions that are down below the Cubeviz app. There's several tasks, and I'd like you to try to follow along and see if you can accomplish those, and we'll have some checkpoints to see how you're doing. So the first thing you want to do is go down below all this, and the notebook cell that says load cube into Cubeviz, and you can ignore that time command there. That's just to make sure that it doesn't get hung up. But what we want to do is to load the data, we're going to use Cubeviz. Oops. And it's app load data, and we can just use the file that we loaded up above. Let's that should work. We shift enter. Takes a few seconds to run. You're going to see a bunch of warnings and that we're working on. It has to do with one of the packages, Spectral Cube, that we're going to no longer be using, so that should go away soon. So if you go back up to the Cubeviz app, let me just pause for a second. Do you have a question? What you'll see in the Cubeviz viewer is a bunch of viewers, just like you had for Mosviz and Specviz. This time what we have is, you look at the gear icon at data, the first three extensions of the cube are shown in the top viewers, the science extension, air extension, and the data quality extension. And we've selected highlighted the first science extension in the first viewer up in the upper left. And first thing we want to do here is to adjust the stretch on this. And if you go to the layer tab and go down to stretch and change it to logarithmic, and you can adjust the percentile on the stretch as well. 99% seems to pull up the wings of the PSF pretty well. Okay. So that is task one, to load the cube and view it. Another thing, since this is a cube, what we can do is there's a little slice slider up on top. So, and if you scrub through that, you can see you look at different planes of the cube as you scrub through. And sometimes it's a little bit laggy, so you can watch out for that. But you were able to see that it did change at first. I don't know what's going on. You can also adjust which slice you're on with the arrow key up above. Okay, once you've done that, the next thing is we're going to try to specify a region in the viewer, the cube viewer, to extract a spectrum. And so to do that, you go to the hammer and the tools icon and select the circular region selection. Initially, since we haven't selected any regions yet, you'll see no selection in the regions up above. And so you'll create a new one. By clicking and dragging, you'll create a circular region like this. And it's actually pixelated, so it's not, doesn't use fractional pixels. So what you'll notice is that the red spectrum that popped up in the spectral view below is basically the maximum flux from one of these spaxels. And what we can do, since we're interested in actually extracting the spectrum inside this circular region, is to go down to the spectrum viewer and change the method for summing. To do that, you go into the viewer tab under the gear icon. And you can change this thing where it says x-axis maximum. That's actually mislabeled. It should be sum method or collapse method. And you can change that from the maximum, which is default, to the sum. And you'll notice that the spectra that are displayed there, both the sum over the whole cube, which is in black, and the extracted spectrum inside the circular region, which is red. And there's less flux in the aperture because we're not including all of the PSF. I can expand that out and get more flux, or reduce it and get less flux, or move it around. So you can modify the spatial regions that you see. So there's a lot of other options you can use in the viewer. We showed the stretch and the contrast. You can also change the color map to something more interesting if you like. We'll go over some of the other options in a minute. So what we have in mind to do is to select part of the spectrum in the spectrum viewer for further analysis. So to do that, what you want to do is you want to leave subset 1 where it is. So we'll go up to the subsets list and select no selection because we want to make a new subset in the spectrum viewer this time. The next thing is to go down to the spectral viewer and select the spectral region selection. This is vertical, this rectangular thing. Here, you do that. Actually, what I want to first do is show you again how you can pan on the spectrum to a feature of interest. And as some of you have noted, there's some trouble with the zooming in this platform. Actually, you'll scroll the notebook as you zoom, which is a little bit irritating. But I've found that with my Mac laptop and the trackpad, you can actually do this okay in a normal Jupyter notebook in your browser. I've only had trouble in this environment, so hopefully it's just an issue here. So once you've zoomed in on a feature of interest, what we want to do is, again, select a range of X values. We're going to select the broad H alpha region here, like this. And the portion of the spectrum that you've selected turns green, and that's hard to see here, so what I'm going to do, as demonstrated before, you can go into the gear icon, select the layer that corresponds to subset 2, which is the spectrum subset I selected. It's green. Set line width to something like 4. So, and you should be able to see the spectral region you selected a little bit better. All right. So the next step we're going to do is to do something with the spectral region. And for that, what we'll do is use now we should be on to task 4, extract an image by collapsing the cube. And we're going to use those regions that we selected. What we want to do is go up to the Lego icon on the upper right. And what I'm going to do is collapse the cube over the spectral feature. So we go to the collapse plugin on the right. And there's a number of inputs. We already have the right data set that we want to collapse, and that's the science extension of the data cube. So we'll leave that as is. You can collapse either along the spectral axis, which is 0, or the x, which is 1, or y, which is 2, I think. But we're going to collapse along the spectral axis so we can make an image of that line. That could be particularly interesting because it's a point source, but this will always show you how to do it. So we actually want to sum over those slices in the cube. Let's sum under method. And then we're going to use this green spectral region, which is called subset 2, which is the spectral region we're going to collapse over, and that's with the bounds indicated in meters over here on the right. Turns out that the default units, I think, are meters on these data sets, but there is a plugin that you can use to change that to microns if you wish. So we've got to here, and then the last thing to do to collapse that cube is just to hit the apply button. You see a message that the collapse was successfully completed. You can close that message. Now, the default images that you see in these viewers up at the top are actually the cubes, the different extensions of the cube. You can use these image viewers for 2D images as well. So what we do is we go in, since the collapse isn't automatically shown in one of these, you want to go into the gear icon, deselect the error to the uncertainty extension, and select the one that says collapsed. That'll show up. And like we did for the cube, you can adjust the contrast. Change it to logarithmic 99 percentile, for example. You can actually display contours over any of these images, but I'm going to make contours on the 2D image. So that's fairly simple to do. You just go again, the gear icon, layer, we're already there, and we're looking at the collapsed data set and the flux. And usually when it comes up, these contours are shut off, and that's why there's a slash through this eye icon. And if you unclick that, you'll see auto contours appear on top of your image. That's not particularly useful, so I'll get to the question in a minute. So what you want to do to change the contours is there's a wrench here, and you can click on that, and it'll allow you to customize the contour level. So there's a little trick, workaround for bug that I'm going to use here by putting a jump character at the beginning. So we want 10 to the 12, 10 to the 13, and 10 to the 14 for our contour levels. And then you can delete the jump character to work around that bug. And what you'll see is that contour levels appear on your image. Added bonus, I'm going to show how to display the contours of that image, the collapsed image, over your cube, because that's you might find useful to overlay the contours of one image on another image of a cube, and that's relatively simple to do. You just go into the data. So we've currently have the whole cube displayed in the upper left viewer. What we want to do is select the second data set, which is the collapsed one. And you can show both of them at the same time. And there's a certain transparency. What we don't actually want to see the collapsed image here. We just want to see its contour. So we go into Layer. We select the collapsed cube, and we can turn off the bitmap. And that makes that image disappear, but we can then turn on the contour. And you get contours just like I showed for the image. You can get the contours of those images overlaid on the cube. And again, you can adjust them. So it's actually nice. You could import any image you wanted into one of the viewers, and then, for example, a radio image, and then create the contours and overlay them on your infrared JWST image like this.